Hello student, welcome and very good morning to you. Today I will be discussing a DPP on electric field due to system of charges, that is DPP 10 of electrostatic. This DPP will be extremely helpful to those students who are preparing for NEET, main, advanced and WB joint. Please write a comment on it because this comment will be extremely helpful for me to make the better video for you. Okay, now let's start. Now the concept needed to solve these MCQs. Look at this, the electric field E, this is the KQ by R square. And electric field due to positive charge is directed away from the charge. And electric field due to negative charge is directed towards the charge. These three concepts will be extremely helpful to solve these MCQs. Now, question number 1. ABC is an equilateral triangle. Charges Q are placed at each corner. The electric field intensity at the center will be. Look at this. This is the positive charge, this is the positive charge, this is the positive charge. So, electric field at this point due to this charge is directed along this direction. Okay. And electric field due to this charge is directed away from it. And electric field due to this charge also directed away from it. Now, the angle between any two electric field is 120 degree. This is the 120 degree. This also 120 degree. This also 120 degree. So, resultant of this and this is equal to 0. So look at this. This is the answer. Okay. Look at this question number 2. The charges Q, the charges Q, 2Q, 3Q, and 4Q are placed at A, B, C, D of a square as shown in the figure. The direction of electric field at the center of the square is along. Look at this. First of all, charge at A. First of all, charge at A and charge at C. First of all, consider charge at A and charge at C. Look at this. Due to Q charge, electric field directed along this direction. And suppose this is the E. And magnitude of E, this is the KQ by R square. And the electric field at O due to 3Q charge is obviously 3. So look at this. This is the 3. In the same way, the electric field due to, so net electric field directed along this direction, this is the 2E. Okay, no problem. The electric field at O due to 2Q charge is obviously, this is the 2E, where E is the KQ by R square. And electric field at O due to 4Q charge, this is the 4E. So resultant field is directed along direction, this is the 2E. So this electric field and this electric field acting at O. So resultant electric field is the angle bisector of this, that is parallel to CB. Look at this. This option is correct. Okay. Next. Look at this. Question number 3. Figure below shows the regular hexagon which charges at the vertices in which of the following cases the electric field at the center is not zero. Look at this, figure 1. Look at this, identical charges at each vertices. Identical charges are placed at each vertices. So, electric field at the center is equal to 0. Okay, look at this. Here, this electric field due to this charge and electric field due to this charge cancel out. Electric field due to this charge and this charge are cancel out. And here, these are this cancel out. So, here electric field is 0. Okay. Now look at this. Here, look at this and this charge produce a electric field along this direction. Here, this and this charge produce a electric field along this direction. And this produces zero electric field. So resultant electric field is directed along this direction. So here E not equal to 0. So option 2 is correct. Okay. Look at this. Question number 2. Two charges 5 microcoulomb and 10 microcoulomb are placed 10 centimeter apart. The net electric field at the midpoint between the two charges. Look at this. This is the 5 microcoulomb and this is the 10 microcoulomb midpoint. So look at this electric field due to this charge directed along this direction and electric field due to this charge directed along this direction. If this is the E1 and this is the E2. So look at this here E2 greater than E1. Therefore, net electric field E equal to, look at this is the K into, this is the 10 into 10 to the power, this is the minus 6 by R square minus K into 5 into 10 to the power minus 6 by R square. So R is the distance of midpoint from each charges. Okay. So look at this, you get K into 5 into 10 to the power minus 6 by R square. What is R? R is the 0.1. Look at this, R is the 0.1 whole square. So look at this is the 9 into 10 to the power 9. This is the 5 into 10 to the power minus 6 divided by, this is the 0.1 whole square. So look at this is the 45 into 10 to the power 5 volt per meter is the electric field. Look at this. Look at this. This is the 4.5 into 10 to the power 6 Newton per coulomb directed towards the minus 5 microcoulomb charges. Okay. This option. Now, question number 5. A cube of side B has a charge Q at each vertices. The electric field due to this charge distribution at the center of the cube will be. Look at this. This is the cube. Okay. Here, charge Q, 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 Q are placed at each vertices. So, as charge is symmetrically distributed about center, so net electric field at the center becomes 0. Okay. So, look at this. Option 4 correct. Now, look at this. Question number 6. Four charges are placed at the corner of a square as shown in the figure having side 5 centimeter. If Q is 1 microcoulomb, the electric field intensity at the center will be. Look at this. Electric field due to this minus Q charge is directed along this direction and this is the E. The magnitude of charge, this is the KQ by R square, where R is the distance of center from the each charges. So this is the E. Now minus 2Q charges produce electric field 2E along this direction. Here Q charges produces electric field along this direction. Magnitude is the E. And 2Q charges produce electric field. This is the 2E along this direction. So net electric field along this direction, this is the 2E minus E. And net electric field along this direction, this is the 2E minus E, that is the E. Okay. So resultant electric field is directed along this direction. So E equal to, this is the 9 into 10 to the power 9. Q is the 1 microcoulomb, that is 10 to the power minus 6. And a distance, look at this, side is the 5 centimeter. So diagonal is the 5 root 2 centimeter. So half of the diagonal, this is the 5 by root 2 into this is the 100 whole square. Okay. So look at this is the 9 into 10 to the power 3 into, look at this is the 10 to the power 4 into 2 whole divided by 25. So look at this is the 18 into 4, that is the 72. So look at this, so E equal to, look at this is the 72 into, this is the 10 to the power 5. Newton per coulomb is the electric field. No problem. Now resultant electric field, look at this is the E, this is the E. So resultant electric field becomes, look at this is the root 2 into E, because this angle is 90 degree. Okay. So look at this root 2 into, this is the 72 into 10 to the power 5 Newton per coulomb. So look at this. This is the 1.02 into 10 to the power 7 Newton per Coulomb is the resultant electric field at the center. Okay. Many thanks for watching this video. This video will be helpful to you for your preparation in NEET, main and advanced. Okay. Thank you.